Every manufactured object starts in a state of pure possibility. At the very beginning of the design process, an idea carries zero physical weight. It is completely unbound by gravity, materials, or assembly lines. This creates a difficult paradox for product teams. The exact moment you have the least amount of physical information is the moment you make your most defining choices. A few rough lines on a screen might look disposable, but they operate as a binding contract. Those early strokes dictate the structural physics, the supply chain logic, and the eventual manufacturing reality of the physical object. The space between that initial sketch and the final manufactured product is known as the gap. Navigating this vacuum is where the highest stakes of the entire product lifecycle are actually held. To understand the true weight of the concept phase, we have to look at how it dictates the final budget. This area chart tracks a product's timeline against its budget. Notice this massive spike on the far left. The vast majority of a product's final cost and its core character are locked in during the first 10% of the project schedule. But watch what happens to this secondary line. This tracks the cost of making changes to those early decisions. As the timeline progresses toward actual manufacturing, revising a conceptual choice climbs exponentially in price. Running out of ideas during the concept phase is rarely the problem. The far greater financial threat to a company is committing to a single flawed idea too early. Engineers are familiar with a physical tolerance stack, how tiny manufacturing variations add up. But there is also a conceptual tolerance stack. It happens when early, seemingly minor design compromises compound drastically as a project matures. In the initial phase of ideation and sketching, decisions are incredibly cheap. Scrapping an idea or pivoting a shape takes seconds. It costs nothing but time to erase a digital line. The secondary phase, machining components, cutting steel tooling, organizing global logistics, is entirely bound by physical limitations. In this phase, decisions are brutal. Moving a millimeter of hardened steel costs hundreds of thousands of dollars and months of delay. Look at this block structure. A single unexamined assumption at the base level forces everything above it to skew drastically outward. By the time you reach the top, the entire geometry is compromised. If a flawed conceptual foundation makes it to the steel tooling phase, that skewed structure is locked in place. The financial penalties and schedule delays become permanent fixtures of the product. When catastrophic, expensive failures are discovered on the assembly line, they almost never started there. They are ultimately traced back to an early conceptual error that survived the gap. Highly successful design teams operate differently to mitigate these compounding downstream risks. They use a strategy called front-loading exploration. Instead of rushing to a prototype, they intentionally delay making physical commitments. They use that extra time to exhaustively map out their conceptual options. By generating and comparing dozens of variations side by side, they actively prevent accidental lock-in. They force the design to prove itself against alternatives before a single purchase order is signed. This approach takes the bulk of the heavy engineering work out of the physical realm and pulls it entirely back into the digital realm, where iterations are still virtually free. Winning teams exhaust every conceivable iteration inside the gap. By the time they move into physical production, there are no structural surprises left to uncover. No matter how much you explore, you eventually hit the irreversible line. This is the absolute threshold, where exploration has to stop and hard financial commitment begins. Historically, teams rarely hit this line with total confidence. Technological friction and strict production deadlines usually force them to pick a direction before they had time to test every variation. Depix is engineered specifically to eliminate that friction and safely bridge the gap. It gives teams the ability to rapidly cycle through comprehensive, instantaneous iterations. You can view the product from every structural and material angle in real time, long before committing to a final path. Achieving that kind of instantaneous speed delivers something critical: the psychological and financial confidence required to finalize those physical specs. The irreversible line of physical tooling will always exist. Regardless of the tools you use, you will eventually have to cut steel. The difference in the final product comes down to how you reach that tooling deadline. Did you cross the line by accident because your team ran out of time? Or did you cross it intentionally because you mapped every inch of the territory? A design decision is cheap as a sketch and brutal once tooled. Seeing every angle before you build is the only way to ensure the line is drawn on purpose.